Now we take a look at how to represent relations and functions with graphs, and also how to find the domain and range, domains and ranges of them. So let's start by looking at a graph and analyzing it. Okay, so here I have a graph and I've named this f, this relation f. And so how do we, let me move this a little bit, how do we interpret what this graph means as it relates to relations or functions? Well, the first thing we need to know is what does that open circle mean? What does the arrow mean? The open circle means the graph gets infinitely close to that point, but doesn't include that point. Okay, so that's important to know. The arrow means the graph continues forever in that direction. A closed circle means the graph stops at the point and the point is part of the graph. The point is, let's say, included in the graph. Up here, the open circle means the point is not included in the graph. It's a stopping point, but the point's not actually included in the graph. So what are some things we can say about this relation? Well, the first question we could ask is the relation f a function? And so how do you determine if something is a function? You try to figure out if each input, x value, have exactly one output. Okay, so we come over to our picture here, and we may not know the answer immediately, but what we can do is we can start picking inputs and seeing how many outputs they have. For example, if I pick an input of 5, x is 5 anywhere on this vertical line, you can see that on a graph, the only things that are represented are the things that are shaded. So here, I do have a point. So if x is 5, y is 6. So it does have an output of 6. So the input of 5 has an output of 6. So I can write that over here. Input 5 has output 6. Okay, so the input of 5 has one output. So we start scanning the inputs, right? We start scanning the inputs, keeping in mind that this graph goes forever up and to the right. Scan all the x values and see if any of them have more than one output. So for example, over here, the input of -3. The input of -3, x is -3 anywhere along this vertical line. This input has one output of -2. And you can see that if you scan every single input and search for outputs, you're not going to get more than one. So the answer to the question is f is a function because each input has no more than one output. Okay? So that's how you determine if a graph represents a function. Okay, so now it's the same function, and now I want to say, write the domain and range of this function f in interval notation. So let's look at the domain, and let's make a number line for it so that I can convert it to interval notation. And so the domain is the x values that are represented on the graph. And in this case, you can see that 4 has an output, 4.5 has an output, right? So any input that has an output is in the domain. And you can see that every input starting here, every input, all these x values have a point on the graph, have outputs. Okay, so the domain is all of those inputs. Well, how do I describe those on a number line? Well, I mark -11, and that point is open. That point's not part of my graph, so I have to put an open circle at -11, my x value of -11. But all the x values to the right of -11 are in the domain, so I shade all of those. And so that is my domain, and in interval notation, that's -11 to infinity. Now I do the same thing for my range, or my y values. It's a little bit harder. The range is all the y values. So you scan your y-axis and you find y values that are represented on the graph. And you can see that your y values, you don't have any y values below -3, but you do have all of the y values above -3, and including -3 because of this point right here. So we know that -3 and above is in my range. Now some people would say, hey, what about y equals 4? What about the output of 4? Well, 4 is in my range, not because of this point, but because it's included over here, right? This point is shaded. So 4 is in my range. So my range is everything from -3 and bigger. So whenever I turn my range horizontally to turn it into this number line, -3 I put on here, and numbers bigger than -3 are to the right. So I include -3 because I said this point here at the vertex, if you will, is included, and everything bigger than -3, so I go to the right. And so my range is -3 to infinity. So that's the domain and range of this function. So now I have a different relation, g, with its graph given, and I've got some questions over here, such as, is g a function? So what I do is I scan my inputs and see if any input, so does any input have more than one output? So as I'm scanning, I start to notice over here, such as whenever x is -6, my input's -6, I get an output up here, and since this line goes on forever, I will also get an output down here. So -6 does actually have two outputs. So the answer to the question, is g a function? The answer is no, because the input -6 has two outputs. Second question, write the domain in interval notation. So I've got to locate all the x values that have outputs on this graph. And so, for example, does -11 have an output? Well, sure it does, because this line here goes forever to the left. Now you don't want to think about these as two separate graphs. This is one graph. It just happens to have two pieces. Okay, so -11 is in my input because there's an output to it down here eventually when this line hits it. So in fact, since this line goes to the left forever, my domain goes to the left forever. All my x values to the left forever are part of the graph. Well, if I keep going, x values at -8 and to the right actually have two outputs, so of course they're in the domain. And then what about x of being -4? Does it have an output? Well, it does not have an output up here because of the open circle, but it does have an output down here because of this line. So yes, -4 is in the domain. So my domain just continues, and suddenly it stops right here at 3 because there are no x values represented past 3. So my domain, if I draw a number line of it first, my x values, my domain, I know it goes to the left forever and then stops at 3, but includes 3, right? Because this point is a closed circle, so it is included. So my domain looks like this, which is -infinity to 3. My range is all my y values, and I can see I have a gap in y values between 2 and 4. But from 2 down, this graph goes down forever, so my range goes down forever. And then up here, it starts up at 4, not including 4, and goes up until it reaches 8 and stops again because there are no y values past 8. So my y value number line, my range number line, looks like this. The negative side is the bottom here, and it goes and goes and goes and goes until it reaches 2, and it includes 2, and then there's a gap from 2 to 4, and then I start back up at 4, not including it, and I keep going up to 8, and I include 8. So my range is my union of those two intervals, negative infinity to 2, union 4 to 8. Sorry, that should be a bracket on the, and that should be an 8, not an infinity. It's not the first time I've made that mistake. So now we can determine if the graph is a function, we can determine its domain, and we can determine its range.